persistent pulmonary hypertension of newborn along with ASD, VSD and PDA. In this 4-chamber view, you can see the right atrium, right ventricle dilated compared to left atrium, left ventricle. Though the view is mainly right ventricle oriented one, so normally right ventricle oriented one, you will get bigger right ventricle and right atrium, even if it is relatively small. In spite of all that thing, this case has got a large right atrium, right ventricle compared to left atrium, left ventricle. The next image is, now you see that this is right pulmonary, left pulmonary artery, and then patent ductus arteriosus PTA. This highly turbulent flow is PDA, patent ductus arteriosus flow. So you get what you get in this image. This is PDA. This is the location of right pulmonary artery. This is location of left pulmonary artery branch, and the most lateral one, most left-sided branch is patent ductus arteriosus. So you get, this is follow in patent ductus arteriosus. So this case has got follow in patent ductus arteriosus. So you get branch wise. You get this right pulmonary artery. You see the cursor, this right pulmonary artery, this is left pulmonary artery, and this place has got patent ductus arteriosus, through which you can see the turbulent jet, that is mosaic color jet, is easily seen. So whenever you are confused how to find PDA, the PDA is most left-wise, most left-sided flow whenever you see the branches of main pulmonary artery. Right pulmonary artery branch, left pulmonary artery branch, and most lateral one is PDA. Next image, you can see this PDA has got bidirectional flow. Just see, this PDA has got bidirectional flow. This is flow from left to right. That means the aorta has more pressure that of pulmonary artery. Now the flow is right to left. You see the flow is right to left, blue in color. So ultimately in this phase of cardiac cycle, the right has got more pressure compared to left. That means pulmonary artery has got more pressure that of aorta. So that is why flow is blue in color, that is flow has reversed. So this case has got bidirectional flow through PDA, though mainly left to right. Compared to right to left, left to right is more. You see the flow is bidirectional in PDA. You can see the right pulmonary artery branch, left pulmonary artery branch, and then most lateral one, most left-sided is PDA. The next image, same thing. You can see right pulmonary artery branch, left pulmonary artery branch. Just to hold. Now see, this is right pulmonary artery branch, this is left pulmonary artery branch, and this location is of PDA. So right pulmonary artery branch, left pulmonary artery, then PDA, and PDA has got bidirectional flow indicating raised pulmonary artery pressure. So pulmonary artery pressure is raised because of, you see, the flow in PDA is bidirectional. Next image, you see this is muscular VSD, and now you see the VSD has mainly blue flow. Blue means flow from right ventricle into left ventricle, indicating right ventricle has got more pressure compared to left ventricle. That is why flow is from right ventricle into left ventricle. So ultimately indicating the right ventricle systolic pressure is quite raised, indicating raised pulmonary artery pressure. If there is no pulmonary stenosis, pulmonary valve problem, then right ventricle systolic pressure indicates that of pulmonary circulation also. So now you see the flow is mainly right to left. For very initial part, flow is red. You see, just flow is red. flow is red. So very initial part, the flow is red, mainly it is blue. So if flow is mainly blue in color, indicating raised right ventricular systolic pressure. Raised right ventricular systolic pressure means raised pulmonary artery systolic pressure. That means persistent pulmonary hypertension of newborn. Next image is again the same thing. Right pulmonary artery branch, left pulmonary artery branch, and then patent ductus arteriosus, and that has got bidirectional flow indicating raised right ventricular systolic pressure, raised pulmonary artery systolic pressure. Next image, again you can see two muscular BSD in this image. This is parasternal short axis view. You can see the LV is D-shaped. This chamber is left ventricle, and left ventricle has got D-shaped. You see the D-shaped, like D-like a structure. And right ventricle is dilated compared to left ventricle. That is also seen in this view. At the same time, left ventricle makes D-shaped structure, indicating raised right ventricular systolic pressure. And at the same time, you see the BSD with most of the flow from right to left, indicating raised right ventricle systolic pressure. Now you see raised right ventricular systolic pressure. Same thing again. Now the ASD has got mainly left to right flow. You see in this image, this part, this is ASD, and flow wise it is mainly red in color. So this is red in color, indicating left to right flow. So flow is mainly left to right here. At the atrial level, mainly from left atrium into right atrium. Then at ventricular level, mainly from right ventricle into left ventricle. And then PDA level, almost equal or mainly left to right. So ultimately, this case has got persistent pulmonary artery hypertension with ASD, VSD, two muscular VSD, and patent ductus arteriosus.